Today I will be covering predicting reaction output. I summarized this process into 3 simple steps. Step 1, balance chemical equation. Step 2, work in units of moles. Step 3, divide and multiply. If you're unfamiliar with balancing chemical equations or working in the units of moles and converting between grams and molecules, you can check out my earlier videos where I cover those topics. Anyways, I'm going to use this example that I have written down to show you how I attack these problems using my 3-step process. The question is, given 200 grams of butane, how much water can be produced? So it's not specific to water. We could do the same problem and look at how much carbon dioxide can be produced. I do want to say that this question is assuming we have an excess amount of oxygen. And so let's just start with step 1, balancing the chemical equation. This is just a normal combustion reaction, as you may have seen in some previous videos. So we have 4 carbon on our reactant side, so we want to put a 4 here. We have 10 hydrogen on the reactant side, so to balance it we need 5 in front of the water. And we see we have 13 oxygen molecules. That's 8 plus 5 is 13. To make this equivalent, we do 13 divided by 2. To make it all reasonable, we need to multiply the entire reaction by 2. So 2 here, and 13 oxygen molecules on the reactant side, 8 carbon dioxide molecules, and 10 waters. Awesome. So we just completed step 1. Step 2, we need to work in units of moles. So we're given 200 grams of butane. To convert to moles of butane, we need to know the molar mass. The molar mass of carbon is 12. There's 4 of them in this molecule, so 12 times 4 is 48. Similarly, hydrogen has a molar mass of 1, and there's 10 of them, so 10 times 1 is 1. 10 plus 48 is 58, so for every 1 mole of butane, we have 58 grams. If we were to do this math, we would find that we have 3.45 moles of butane. So now I've just completed step 2. We converted what we have in different units to units of moles. And now we go on to divide and multiply, which is very vague, but I will show you how I do it. So we know that we have 3.45 moles of butane. Just erase some of the work I've done to give me a little bit more room. Okay, and we want to know how much water is going to produce if this reaction went to completion, right? So divide and multiply. It's important that you divide first and multiply later. What I am referring to is looking at the coefficients in front of the molecule that we're given and the coefficient in front of the molecule that we're interested in. First we divide and then we multiply, as hopefully it's implied. The way I do it, I put moles of the molecule that we're given, and then I draw a line from the coefficient down, and that indicates a divide. And then I draw a line that moves over to the molecule we're interested in. Actually, let me just make it move to the molecule we're interested in, and that indicates a multiply. Okay? If you were to do the math, you would find that you would produce 17.24 moles of water. Now, if you're, again, interested in getting it in units of grams or something else, you need to take it one more step by saying, okay, if we have 17.24 moles of water, how many grams did we produce? Well, it's just what we did before, another conversion. We know that hydrogen has a molar mass of 1, oxygen has a molar mass of 16, so it's a total molecular mass of 18. So for every for 18 grams of water, we have a mole of water. So moles cancel. If you multiply this out, we have 310, or we produce 310 grams of water. And that's if the reaction went to completion. So that's the video on predicting reaction output. I'll do a couple more examples in some later videos. Let me know if this was helpful. Let me know if there's anything else you'd like me to cover. Thank you for watching. Bye.